So these are your examples for multiplying a vector by a scalar. At this point in your mathematical journey, you will not be able to multiply two vectors together. That will not happen until higher or advanced higher or even beyond. Okay, so multiplying a vector by a scalar. How do we start and what does it mean? So remember that we can have vectors such as u. And we know that u goes along 2 and up 3. So we represent this vector as u equals 2 along the x, 3 on the y. But then we can also have things like 2u. I've got to think about what that means. So that means one lot of u and a second lot of u. And each of these will be along 2 and up 3. Along 2 and up 3. 2u, therefore, as a vector is going to be in total 4 along and 6 up. Okay, so if we're doing this graphically, this is what we can do. We can write it all out, and what you were doing is seeing what that final vector movement is. However, we don't like to draw it all out all the time. Life is easier if we can do things just computationally. So what are we looking at? Well, we know that u is equal to 2, 3. And you could be asked to find 2u. So that is going to be 2 times the vector. 2 lots of the vector. Now, everything about this, both the x and the y's, is going to be 2 lots of it. So we're going to have 2 times the x and we're going to have 2 times the y. And then we are going to simplify that down to 4, 6. As you can see, we've got the same answer, but we didn't have to do the drawing to figure it out. So let's have a look at a second example. So what about if we know that v is equal to minus 1, 2, 3? Okay, what would 3v be equal to? Well, we start the same way. We state what the problem is. It's going to be 3 times minus 1, 2, 3 in brackets. Then you multiply those together. 3 times minus 1, 3 times 2, 3 times 3. And you simplify it down. So 3 times minus 1 is negative 3, 6, 9. And that is you done. Okay? So this is the core skill. You just need to know that when you multiply by a scalar, that 3, you are multiplying everything in the vector by that 3. Now, in terms of problems, you can still get ones which are combinations. So you could have 3u plus 2w, okay? And you would be told u equals negative 1, 2, w equals 3, 4. You have to do this sum. So you're going to have to do it in 2 parts. It's your choice whether you deal with the 3u and the 2w separately, then bring them together, or whether you do it all at once. And I'm going to leave that up to you to decide, but I'll do it all together. So we've got 3. So I've got 3u plus 2w. So that's going to equal 3 times negative 1, 2, plus 2 times 3, 4. In the brackets, simplified. And then we've reached this point, we've dealt with all that multiplication. We've got to consider how we're going to add them together. And what we've got to do is minus 3 plus 6, 6 plus 8. I'm just going to do it at the side here. We're going to end up with 3, 14 as our final vector. Okay, so this is probably as far as you'd be expected to go with taking scalars of a vector, and you just need to know that you deal with the multiplication before you deal with the addition and subtraction, the same as you would in BODMAS. Now there's one final example I'm going to show you just because it will come up, is if you can multiply something by 3, you can also divide it by 3. So if you had, let's make it vector m equals 3, 12, 9, and you're asked to find a third of vector m. What you're going to do is take a third and times that by your vector. A third of 3 is going to be 1. Remember, you can just divide by 3, that's taking a third or something. And that'll leave you with, oh, sorry, correction. I did the answer before I did the question. So we've got 3 divided by 3, 12 divided by 3, 9 divided by 3, and then we get to put those answers into our final vector.